Good afternoon, students. And last lecture we have discussed about the motor types of motor, electrical motors. There are three types of motors that are used in the industries: induction motor, synchronous motor, direct current, direct motor. Right. Then we have discussed about the parameters of the motors. Few parameters like efficiency of motor, power factor of motor, RPM, speed of motor. um, then we have discussed about the motor selection also. There are few Indian standards by which we can select motor, right? There is no need to check the motor. We can purchase motor by direct with the help of label. Next is energy efficient motors, that is EEM. This is very important part, that we have to create or manufacture energy efficient motor, because this subject teach us हमें ये subject बताता है कि आपको मैक्सिमम जो है एनर्जी सेव करना है, राइट? एनर्जी सेविंग के ऊपर ये कॉन्सेंट्रेट करता है. तो फर्स्ट पॉइंट इन दिस EEM. Here EM are ones in which design improvements are incorporated specifically to increase operating efficiency over motors of standard design, right? Next, design improvements focus on reducing intrinsic motor losses. Improvements include the use of lower loss silicon steel, longer core, thicker wire, thinner laminations, smaller air gap between stator and rotor. Okay. See here, copper instead of aluminum bars in the rotor, superior bearings and smaller fan, etc. These can be used to improve the efficiency of the motor, right? Next point, energy efficient motors now available in India operate with efficiencies that are typically 3 to 4 percentage points higher than standard motors, in keeping with the stipulation of the BIS. And energy efficient motors are designed to operate without loss in efficiency at loads between 75% and 100% of rated capacity. This may result in major benefits in varying loads application. The power factor is about the same or maybe higher than for standard motors. Furthermore, energy efficient motors have lower operating temperatures and noise level, greater ability to accelerate higher inertia loads, and are less affected by supply voltage functions. See here, we have to discuss also energy efficient improvement in energy efficient motors, that the area we can improve the function, right? There, suppose this is power loss area and this is efficiency improvement. See here, iron. See, in this iron, power loss area is iron. Use of thinner gauge, lower loss core steel, reduce AD current losses, Longer core adds more steel to design, which reduces losses due to lower operating flux densities, etc. Second, this is first, this is second. Stator is I square R. This is use more copper and larger conductors, increases cross sectional area of stator winding. This lowers resistance R of the windings and reduces losses due to current flow. Rotor here in rotor, use of larger rotor conductor bars, increasing size of cross section, lowering conduction resistance R and losses due to current flow. Fourth one is friction and winding. Right, use of low loss fan design reduces losses due to the air movement. And fifth one is stray load loss. Here in this stray load loss, use of optimized design and strict quality control procedure minimizes the stray load loss. Next, adjusts electric light level up or down to maintain desired light level on the work surface. Next, affected by both electric light and daylight. And next, so we stop here. To discuss this portion, energy efficient motor, then we have to discuss about some loop sensor setup. So there are three types of loop sensor setup. So we are going to discuss one loop sensor loop sensor setup in the offices, right? We are going to discuss open loop. Here, open in this approach, daylighting, the illumination at daylight sensor varies. It has wide field of view. The sensor doesn't look directly into space that contain the lights that it controls. So I'll draw the open loop center for in the office like this. Suppose this is office. Suppose this is table. This is chair. right? This is about the open loop sensor setup. Private loop, another point is private loop. I'll draw a diagram for private loop also. Neutron approach in a partial open loop daylight sensor are positioned inside the physical space and take into account the light levels penetrating the area from natural light source, as well as light contributions from the work surface. This approach combines both open and closed loop methods, right? Then we have to discuss next point, artificial energy efficient illumination. Next point is artificial energy efficient illumination. See here, in this convenient and effective artificial lighting is one of the important advance of 20th century. Artificial lighting allows to use to work and play inside and outside our homes independent of the time of the day, and also often serves aesthetic purpose. Artificial lighting is generally employed for these for types. First one is ambient lighting. Task lighting and accent lighting. In this, ambient lighting provides general illumination indoors for daily activities and outdoors for safety and security. Second one is task lighting. Facilitates particular tasks that require more light than is needed for general illumination, such as under counter lights in kitchens, table lamps, or bathroom mirror lights. And third one is accent lighting. See here in this draws attention to special features or enhances the aesthetic qualities of an indoor and outdoor environment. Recent technological improvements allow home owners to substantially reduce the energy they use the lighting without loss of amenities. See here, there are few advantages or benefits of lightings, advanced lightings. Artificial lightings consumes almost 50% of household electricity The traditional bulb with a screw base currently provides most household illumination. Use new lighting technologies can reduce lighting energy use in home by 50 to 75%. Advances in lighting controls offers further energy savings by reducing the amount of time lights on but not serving a useful purpose. Advances lighting controls also offer a new amenity light that can come automatically where they are needed. Some advantages of this advanced lighting. In general, this can save energy. This is 25. This use 20 to 85% less energy than the traditional bulbs. Next, last longer. The energy efficient bulbs last much longer than traditional lights. In fact, they have been proven to last between 2 to 35 times longer. Emits less heat. See here, traditional bulbs spend about 90% of energy on heat and 10% on producing light. Energy efficient bulb do not emit as much heat, so won't be incredibly hot to that much. Saves monies. It estimate that you will save 5,000 per year if you change the five most frequently used bulb in your homes to the energy efficient bulb. Disadvantages: this is more expensive. One of the main setback of energy efficient lighting is cost. Compact fluorescent bulb can cost anywhere from 200 to 1000. Traditional bulbs are much more inexpensive, so many people turn off by price by energy efficient option. Indoor outdoor lighting types. There are varied lighting technologies for all lighting situations. Consideration should be given to every energy efficient lighting choices in fixtures that are on for more than 2 hours a day. So there are some types indoor lighting, that is utility lighting, pole mounted lighting, flood lighting, then accent lighting, then task lighting, then ambient lighting, so we have discussed about the energy efficient that is artificial energy efficient illumination. And in next lecture we have to discuss about the interior lighting options, the daylight lighting, incandescent lighting, fluorescent lighting, indoor lights, controls. So I'll stop here. Thank you very much.